Welcome back. So we're going to look at the vertical circular motion cases in a few different kinds of questions. There's not too much stuff that can be asked of you with these things, as long as you know which situation you've got and the equations that you can apply to those situations, and the fundamental ideas, such as you feel heavier or you feel lighter in these particular situations. As long as you've got all that down somewhere, then there's not too much else that can be asked of you in these kinds of questions, okay? Because we're really only just analyzing basic stuff about that motion, which is at the top and bottom of those circles. All right, so let's have a look at a question. Well, first of all, let's look at our strategy here. So how are we going to tackle these problems? Well, first of all, figure out which situation you've got. That's number one, right? Is it the bottom of the dip? Is it the top of the hump, top of the hill? Or is it at the top of a loop-the-loop? Which one have you got? All right. Then look for any information telling you about any constraints. So things like your car is just about to leave the track or something like that. Okay. Then write down what you know. Okay. Have that information on standby. So you'll need to write down things like mass, radius, speed, whatever else they want to give you. And then really it's just, figure out exactly what the question is trying to ask you. Is it asking for a velocity? Is it asking you for, normal force? Is it asking you for radius? What are they asking you? And just write down the equations you need and try and solve it. Okay? So let's have a look. Question 7. A person of mass 60 kilograms travels in a car through the bottom of a dip. So let's draw that. At the bottom of a dip, at a velocity of 36 kilometers per hour. The radius of the circular path it takes is 20 meters. Calculate the apparent weight of the person at that moment. Okay, so we've got an idea. Here's our situation. It's the bottom of the dip. Okay, that's very obvious. What else do we have to do? Well, there's not really any constraints. Okay, it can go as fast as it likes down this dip. It can go as slow as it likes. Okay, it's really just analyzing forces question. Okay, the question is, calculate the apparent weight. And we've got to remember what apparent weight means. Okay, apparent weight is interchangeable with the phrase normal force. Okay, so really the question is just asking you, what is the normal force at that point in its motion? Okay, so let's write down what we know. We know the mass, 60 kilograms. We know the speed. Now, just be aware that everything has to be in meters, seconds, and kilograms. So convert 36 kilometers per hour to meters per second by dividing by 3.6, and we get 10 meters per second. And the radius is 20 meters. Okay, so what equations do we have? Well, that should be in your notes somewhere. And you should have the equation giving you the normal force for this kind of situation. And that equation is normal force is equal to gravitational force minus mv squared on r. Okay? And we've got all of these quantities, okay? Fg, gravity, that's just mass times 9.8. And we've got v and we've got r. So just put it all together. So we're going to have 60 times 9.8 minus, oops, sorry, it's not a minus. What am I talking about? Rewind a bit. That should be a plus. So we've got plus there. Sorry. So 60 times 9.8 plus 60 times velocity, which is 10 squared over radius, which is 20. Okay. And we get an apparent weight of 888 newtons. There you go. Okay. So that's the apparent weight that this person is experiencing at that point in time. Now you can ask a related question. What is the apparent mass? Okay, so you don't hear that phrase too often, but if you were to now translate this weight into a mass, well, how exactly would you do that? Okay, well, think about just normal weight and how you translate your mass into a weight. So weight, you've got to remember, is the force due to gravity, okay? And to calculate force due to gravity, it's your mass times g. So if we're working out apparent mass and we've been given apparent weight, then the apparent mass is equal to the apparent weight, which is just the normal force, divided by acceleration due to gravity. Okay, and what this will give you is what a set of scales would read if you were sitting on them or standing on them at that point in time. Okay, normally the scales give you a reading in kilograms. This is what the scales would read. Okay, so the normal force we've calculated is 888 divided by G, 9.8, and we get 90.6 kilograms. Okay, so a person who is normally 60 kilograms would have a reading of 90.6 kilograms if they were on some scales at that point in time. Okay, and that just goes to show you that you do actually feel heavier when you're in this kind of situation. All right. Okay, so next question. A roller coaster designer must design a loop so that the cart does not leave the track at the top of the loop. If the loop has a radius of 10 meters and the cart has a mass of 200 kilograms, how quickly must it move so that it just stays on the track? Okay, so here's our loop-the-loop. It's very obvious that this is a loop-the-loop question because it basically tells you. There's our cart. Okay, and notice with these questions, I'm not actually drawing any forces in, okay, because we've analyzed that before. We've got all these equations to help us. You've just got to identify which situation it is and look at the equations for that situation and apply the right equation, right? Anyway, so there's our cart, there's our loop, and the question is saying how quickly must it move so that it just stays on the track? Just stays on the track is basically us working out what is that minimum speed. Okay, what is V min? Okay, so the question is asking what is V min? All right, minimum speed we need to make it all the way around without leaving the track. So write down what we know. Mass is 200 kilograms. Radius is 10 meters. We don't know V, that's what we're trying to work out, and really we don't need any other information because, luckily for us, the minimum speed equation only relies on the radius, and G of course, but G is a constant, so there you go. Okay, we plug our values in, 9.8 for G, times 10 meters, and we get basically the square root of 98, which is 9.9 meters per second. So the roller coaster designer must design his roller coaster so that at that point in the roller coaster's motion, it's traveling at 9.9 meters per second. And actually later on when we start looking at energy and transformations from kinetic energy to potential energy and vice versa, we can actually calculate how far up sort of it had to be here so that if it would start at rest or even if it started with some velocity, how far high that would be so that by the time it went down and up and around, it actually had that particular speed. But that's in another bit of this area of study, so we'll do that later. All right, question 9. A car of mass 2,000 kilograms travels over a hill. So here's our hill. At a speed of 20 kilometers per hour. The hill forms part of a circle with a radius of 12 meters. Will the car get some air? Okay, so the question is, will it leave the track? Is it going fast enough to fly off? Okay, is it going faster than Vmax? Is V greater than Vmax? Okay, that's what we're being asked here. So all we've really got to do is calculate Vmax and compare that Vmax to the speed of the car. And if the speed of the car is greater than Vmax, then yes, it gets some air. If not, it won't get some air, okay? So how do we calculate Vmax? Well, that is just square root of G times R. And in this case, the radius is 12 meters, so it's going to be square root of 9.8 times 12, and your calculator will give you 10.8 meters per second. Okay, so that's Vmax. The speed that the car is traveling at is given to us in the question as 20 kilometers per hour. So changing that to meters per second is just 20 divided by 3.6. And we get a speed of 5.56 meters per second. Okay, so the speed the car is traveling at, that one is less than Vmax. So no, it will not get some air. It will remain on the track and go along its merry way off to wherever they're going. Maybe they're going to a market, who knows, by some practice physics exams. Anyway, that's it. That's it for vertical circular motion. That's all it is. Okay, you've got 3 situations to analyze. Each situation has their own bit of equations that go with them. And your job when you see a question is to think about, okay, what situation is it? What am I being asked to find out? And really you can only be asked to find apparent weight, which is the normal force, or Vmax or Vmin, depending if it's a loop-the-loop or, going over a hill. Okay, so I'll leave it there, and I'll see you next time. Bye-bye.